Okay, good morning, everyone. I'm Emanuele Mercanti, and today I'll talk about machine learning for privacy-preserving advertisement. So it's 2024, and we've come a long way since the first inception of digital advertising. This is how it looked like in 1994 when they first appeared. So over the past 30 years, we've learned how to understand what the consumer wants, and we have perfected ways of delivering it to them, increasing revenue for us and consumer satisfaction, hopefully. Digital ads looked weird back then, and I bet they look also weird and annoying today. And despite that, things have gone pretty good in the trajectory. If it wasn't for one tiny detail, and it is that sometimes ads are spooky. So despite working in ads, I've always been hostile towards advertisement. I live with a lot of ad blockers on, and I get afraid when I see ads knowing a little bit too much about me. Let's say I'm talking with a friend about wanting to buy a new pair of sneakers, and out of the blue suddenly, boom, ads about sneakers everywhere. How did this happen? I didn't use any browser, I didn't Google anything, I didn't look at any social media posts. So is my phone spying on me? How did they infer my interest about sneakers? Now, everybody who has ever felt the same, please raise your hand. I see a lot of people. It's good to know that I'm not the only one, and even better to know that I don't sound like I wear a tinfoil hat. So we're not the only one sharing this concern. Let's take Americans, for example. 8 out of 10 people worry about how much companies know about them. And the situation looks similar in Europe 10 years ago. But today, thanks to the GDPR, only 4 out of 10 people worry about sharing personal data online. If we go on the other side of the world, however, in Japan, a staggering 9 out of 10 people worry about their browser history and sharing their personal info. That's 2 times the amount of people who worry about online fraud. That's big. And trends are similar also in India, Mexico, and we can see all over the world. That's a worldwide phenomenon. And across the globe, 7 out of 10 people are worried about their online privacy. But why this is happening? We can think that there is somebody out there committed to make our web experience hell and constantly on the lookout for the most private detail that they will use to sell us stuff. And that's me, I work in ads. No, just kidding. But this is not happening. What's happening is that the industry has adopted bad advertising practices. And those practices are harmful. Bad advertising is being interested in who you are, and then using that to infer what you want. So, in an ideal world, let's say that a user is using the platform they love, for example Reddit, and they trust the platform to keep their personal data safe. However, when advertisers plug in, this implicit relationship of trust gets eroded. Knowing that I'm seeing an ad because of my age, my ethnicity, or who my friends are, doesn't feel right, does it? It definitely doesn't feel right to me. And because of that, users become reluctant to click on ads, since their privacy is harmed. And this hurts users, obviously, but this also hurts advertisers, because users don't click on ads, and they keep the negative feelings they were perceiving at that moment associated to the brand. So they will likely avoid the brand in the future. And eventually, this also harms the platform, because users lose trust in the platform. Some stop using it. And as a consequence, you can imagine that revenue drops and everybody loses. So when bad advertising practices are used, it's a lose-lose situation. Nobody wins. But why is it like this? Does it have to be like this? So we should ask ourselves, is another way possible? Can we get relevant ads without using personal data? Can leaders in tech and ad businesses encourage a privacy-first approach? Is there an alternative where everybody wins? Those are a lot of questions, and luckily, the answer to all of them is yes. We can do that using contextual advertising. Contextual advertising uses contextual data, which is data considered in relation to the context in which it appears or the circumstances surrounding it. What is contextual data in practice? Let's look at an example. So this user on Reddit is talking about their favorite games in a comment section. Context here is the brands, the items that they are interested in. So this user is interested in Ubisoft and Blizzard, which are game publishers, and Nintendo Switch, which is a console. So we already have some interest assumptions. The user is interested in games published by Ubisoft and Blizzard, and the user is interested in games playable on Nintendo Switch. That's easy, but reality is not easy, usually. And sometimes contextual advertising can also go wrong. For example, when we misunderstand the context. So in this case, we are on a subreddit, a community, about Mount & Blade, which is a video game series. And we're looking at a post which talks about Bannerlord, which is a role-playing action game in that series. However, we're seeing ads related to making animated banners with Adobe. So just because the word banner is in the title of the post we're looking at, we're seeing a post about graphic design while we are looking at gaming content. That's not the right context, isn't it? And that's the best case scenario when things go wrong. Things can go very wrong. For example, we might not understand the context at all. Like what? How many of you can understand what's going on? Raise your hands. Few people, because you play those games probably. I do not, and I do not understand what's going on. It took me some Google searches to understand the context. And if this is challenging for humans, imagine how hard it is for a machine. Understanding context is hard. And it is hard because natural language is ambiguous and slang is everywhere. So, are we doomed? Not, because we can use neurosymbolic AI, quite a powerful technique, to solve these issues. Neurosymbolic AI is built on two pillars. The symbolic part, which represents the words using symbols and rules and allows to reason on them, and the neural part, which brings the power of statistical learning and generalization. And with neurosymbolic AI, we can build contextual understanding pipelines in 3 easy steps. First of all, we need to map the content. Second, we need to disambiguate it, because as we have seen, it's often ambiguous. And lastly, we need to find similarities between what's being talked about and things we can advertise, or things we are interested in the real world in general. So let's see how we can do it from the first step, from the beginning. The first thing we need is a knowledge graph. A knowledge graph is a structured representation of knowledge which encodes relationships between different objects and captures similarities between them and hierarchies. The idea of the knowledge graph is to map the semantics and the relationships of the real world between different pieces of information. A knowledge graph, as any graph, is made of 2 things: nodes and edges. So nodes are entities, and they are whatever we want them to be. They can be people, events, dates, abstract concepts, video games, you name it, is there. And edges are relationships between those entities. And we can have many different relationships. We can have games developed by a gaming house, or games playable or on consoles. So that's quite tangled, but it will get clear. Using the knowledge graph is quite straightforward. We just need to match the content we find with the stuff we already know. So in this case, I've played Minecraft on my Switch. We already find Minecraft. And we activate the node in our knowledge graph, and with a hierarchy, we can build a broader context for this. So we know that the user might be interested not only in games similar to Minecraft, but also in games developed by the same gaming house, Mojang Studio. That's reasonable. And for those of you who are gamers, and maybe also who are not, you have also seen that there is another information we can use here, and it is Switch. So we know that this refers to Nintendo Switch, a console we use for games. But machines do not, because Switch is ambiguous. Is it the Nintendo Switch? Or is it just a verb? How do we know the difference? What do we do in this case? We can't just use the knowledge graph here because we are not sure what we're looking at. We might misunderstand the context. So what we do is we call machine learning to help us, and we disambiguate it. So we can create a machine learning classifier, a binary classifier, quite straightforward, which every time we see Switch will tell us, yes, this is the Nintendo Switch, or no, this is something else, ignore it. So after we disambiguate it, and we are sure that we're looking at Nintendo Switch, we can extend the context using the knowledge graph hierarchy. And we can add these in our assumptions. So now you know also that the user is interested in games playable on Nintendo Switch or games developed by Nintendo. All of these interests that we have for the users are very powerful. And just using this 6 words comment, we already have a lot of context on what the user might be interested, on what ads to serve. And we call this the user context. So user context is the set of all things that the user is interested in. And we can do something similar for the ads. Whenever we get an ad, we see at all the entities mentioned there, and we build the ad context. And once you have the two contexts, we can select the perfect ad for the user by looking at the similarities between contexts. If my context is gaming and Nintendo gaming, obviously I won't be shown ads about graphic design. So finding these similarities between the two contexts is done using embeddings. How familiar is this word, embeddings? Few of you. So embeddings basically means mapping any real-world item, such as words, entities in our knowledge graph, concepts, language, into a continuous space. For example, the two-dimensional space, x-y axis. And we do this because this map allows us to preserve contextual similarities and semantic relationships between objects as geometric relationships. For example, distance. So distance measure the similarities between concepts in this case. And using embeddings, we can perform this matching between the best ads and the user context. So first of all, we embed all the entities in our knowledge graph. We map them to this two-dimensional space. And every entity here is represented by a vector, a point in space. Then we aggregate the user context. For example, we can take the average of the vectors, or the sum of them. And we have a new vector, a new point in space, which represents the user context. Then we look at the ads we have in the embedding space. And those, again, will be points. And then it's quite straightforward. We just need to measure the distance between all the ads and the user context. And we select the one that are closer. So that's not rocket science, hopefully. And with this knowledge in mind, this doesn't scare us anymore, because we know how to handle this. First of all, we match all the content we have in the knowledge graph. Sometimes content is ambiguous, so we disambiguate it. And then we extend what we know using the hierarchy. So now we know what this is about. It's not about Edgar Allan Poe or some weird mathematical formulas. It's about Path of Exile, again, Diablo 2, another game, and some Xbox sprinkled on top. And once we have this, we can go to the embedding space and create the context for this particular user. And then we can select the relevant ads by minimizing the distances between the ads context and the user context. This way, from something like a hieroglyphic before that we didn't know what was, we came to the conclusion that the user might be interested in Fortnite, League of Legends, Green Dawn, Xbox games, or Red Bull beverages. It's quite a big leap between the first and the second picture. Bear with me. But now that you know how it's done, it feels quite natural, right? At least it does to me. So, what do we go from here? Now that we know this, what do we do with this information, with this knowledge? We can use it, for example, to help folks in the ads pipeline. We can use the similarity to predict the probability a user will click on an ads. Users which have higher user ads which have higher similarity will probably be clicked on. We can use this to filter, to refine the pool of relevant ads shown. So, for example, by removing all the ads which have a similarity too little with a certain user. Or we can also use this to assess the true relevance of the ads for advertisers. Sometimes advertisers have some ideas on who to target for their ads. But this sometimes is not the ideal target. And we can also show them why, since this method is quite transparent. It's just about seeing what the user is interested in. And what does this mean for the user? For the user, this means that they will see relevant ads without us needing to use personal data. The personal data is safe. We do not need it. We show something to a user because the user has expressed explicit interest about that, not because we inferred it in some weird way by looking at their friends group. And this, consequently, translates in sustainable practices for the platform and for everybody, actually. Because the advertiser is having their ads being highly targeted, and likely they will be clicked on, so the advertiser is happy. The user will see relevant ads, so probably stuff that they will need or want, and even more importantly, they will have their personal data safe, because we don't need it, we only need the context. So the user is very happy. And consequently, this translates to the platform being happy, because it's adopting sustainable practices, it has a growing user base since the relationship of trust is maintained, and it has a steady revenue flow. Everything we might ask for, right? So we have happy users, happy advertisers, happy platform. And what might have seemed impossible just 20 minutes ago now seems quite straightforward and easy, because we know how to do it. And this is the power of contextual advertising. And you should join us in making contextual advertising the new industry standard and drive the industry in that direction. Not using personal data, but using contextual data. Thank you.